In this module, I'm going to discuss security, identity and access management. We have a service which you're going to soon know to be IAM. Believe it or not, is an IAM, identity and access management. And to start with, I'm going to just discuss some concepts about security in terms of securing your infrastructure, and then I'll explain how that works in contrast to what we do in the cloud. Okay. So, physical and environmental security. You would want to obviously lock your data center. This goes without saying. You don't leave everything wide open if you were building your own infrastructure, and you'd only provide access to those that need it. This is this concept of least privilege. You don't necessarily need the cages to the servers open to the cook in the building, that kind of stuff. So you'd be very careful about who you're giving access to. Only give access to people that really need access to those specific machines. You also need to keep track of that to actually prove who did what when in terms of auditing. And of course, even the racks themselves need to be locked. You should also have redundant utilities, meaning if you had a particular power supplier giving you electricity and there was a problem with that, if you had another provider of electricity, it's not the end of the world. We can swap over, you can do backup generators, this kind of thing. And you would need to deal with a lot of security, making sure that security guards all pass certain background checks, this kind of stuff. So the point is here, if you were to try and lock down your technical infrastructure, you're going to have to go through a lot of steps. And it could be complicated and it could be costly. Now, what else do we need to think about? Security of the network itself. It's not just a matter of protecting the physical devices. You also need to think about the firewalls and patching for latest software. If you have a Linux machine and you instantiate that on your server and then later on you never patch it, it's going to be wide open. You're going to have security vulnerabilities. You'll need virus protection. You'll also you'll probably want to encrypt your data on there. Very often, if you have sensitive data from customers, you're going to want to encrypt it. These are additional considerations if you are managing all of this stuff yourself. Shared responsibility. This is an interesting concept because I often get asked this question when I discuss AWS. They usually say to me, how secure is AWS? How secure is the cloud? And it's not that easy to answer. It's a depends answer because there's two component parts to this whole security. Us and you guys, customers. If, for example, we give you a instance which is running, say, Linux, and then you decide, because you have the power to do this, to open up all the firewall ports via security groups and open up to the whole outside world and then broadcast your IP address everywhere. If you get hacked, then that's not on us, okay? So how secure is it? Well, it depends. It depends on what you do. If you do things that aren't that wise, you're going to get your fingers burnt. If you need to have encryption, just because we have a facility that says, okay, we can abide by certain encryption standards and you can encrypt your data in S3, just because you read that we have encryption in S3, it doesn't necessarily mean everything's automatically encrypted. You have to take steps and say, I would like to have my data encrypted at rest. Okay, so there are certain steps that you're going to have to go through. And this whole concept is that we're in this together. This is a shared responsibility. We're going to give you all the tools, but it's up to you what you do. So let's just break this down a little more. I already discussed the global infrastructure concept because this is obviously fundamental. So I'm not going to go through this again. The idea that we have regions and within regions you have various buildings, and AZs as we call them, and edge locations for cache nodes. The foundational services, well, that's up to us to make sure that when you launch an EC2 instance, that it's actually available. When you drop an item in S3, it's going to be there, and it's going to be replicated across multiple data centers. As far as the database goes and the network, well, that's up to us to ensure that that's all running and everything's good in the world. That's when we pass things over to you, and we say, well, okay, we'll give you storage, but it's your choice whether you encrypt it. We'll give you a compute system, like an instance, and you determine what ports you have open on that with security groups. Okay? These are things that you're responsible for. You're ultimately responsible for this one. Okay? Just because, for example, we're allowing you to store pieces of information in any particular region via, say, S3, it doesn't mean you necessarily can. For example, you might be operating some social media website and collecting user data from a certain part in the world that has legal stipulation that says you can't take that customer data outside of that particular region. So just because we give you the facilities to have all these different regions and storage options doesn't mean necessarily that you can do some of this stuff. So again, this whole concept of we're in this together. All right? Physical security. We have staff that are on-prem 24 hours a day, 7 days a week. We also make sure that they're fully trained up, background checks, this kind of stuff. We don't put massive neon signs across all our buildings saying AWS data center, we are here. None of that stuff. They're nondescript, undisclosed facilities. We also have two-factor authentication. Again, I'll maybe look at authentication options a little later on, but it's very tight security. Obviously cameras everywhere, this kind of stuff. And they need specific access for specific buildings. Just because I work for AWS doesn't mean I can wander into a data center. I can do certain things that other people can't do, and other people can do things that I can't do, that kind of stuff. So it's based on least privilege. As far as the hardware, software, network goes, we will change servers out when they need replacing. We're going to monitor all of the network going in and out of the entire AWS system, just to make sure that there's nothing nefarious going on there. We can track things like distributed denial of service attacks, and we have some internal secret source there to kind of make sure that we can mitigate that as much as possible. Although there are steps that you can take because of the shared responsibility to mitigate that even further, but there are some bases we cover in terms of security and monitoring. Goes without saying, we monitor all recorded access attempts, that kind of stuff, as you'd imagine. Certifications and accreditations. I'm not going to read these acronyms out to you. You can see what they are. So for example, if you need to meet a certain compliance, say PCI, maybe dealing with, say, credit cards, just because we are PCI compliant, you still have to go through some steps. You can't just say, well, I'm just going to store my customer's credit card details in plain text in a DynamoDB database because Amazon say they're PCI compliant. No, it's a shared responsibility. If you take the steps towards PCI compliance, our end of the bargain is in place. Okay? We will make sure that we're doing all we can at our end and what we're supposed to do in terms of helping you meet PCI compliance. I hope that's clear. So I want to talk a little more about some concepts related to security in your data, and I'll start with SSL endpoints. You've probably seen a web browser that's got one of those green padlocks on the top corner like this, and that says the website is secure. Whenever you go to a secure website, you'll see that. That means your browser is using SSL, and really what this is referring to is if this is you and you're trying to send a piece of data, and this could be plain text, and you're trying to send this into your data center in the cloud, so it sits in here. Is this transport mechanism locked down and secure against attackers? Okay, so that's really what this is. This is SSL endpoints that you have, and allows you to communicate essentially across that protected pipe. Now, if you wanted to, and you quite easily could, you could lock down your data here in terms of encrypting your data on the client side and then sending it across a non-SSL endpoint. It's still encrypted. However, the best approach really is to just use SSL, and if you wish to, have encryption here and send that across there as well. So the downside with encrypting here, if you then store that in the cloud as encrypted, you have the key. That's supposed to be a key. Terrible drawing. And that key is the only thing that can unlock that. In other words, if you lose that key, you can't get that data anymore. Very often a better approach would be to, if this is again you send your data over SSL, and that drops in the data center. This can be in plain text because you're going over that secure channel. Okay, it's like you see this when you add passwords to a website. You know, if they ask for username and password on a secure certificate, you're going to send that essentially in plain text. But then when it lands, we can do encryption at rest. So this is encryption in transit and encryption in rest. Okay, and there are options you can use here to encrypt your data at rest. So that's the SSL concept. Once you have infrastructure in the cloud, there is another level to security, and that is which ports you have open on your machines. I mentioned it earlier, you don't want to have all the ports open to the whole world. You would only open certain ports. If you're hosting a website, for example, you might only want port 80. If you're hosting a secure website, you'd be using port 443. So you only open the ports that you actually need. And if you want to shell in, via the command line from a Linux box, you might want to use port 22, and so on and so on. VPC, I'm going to save that for a different module. I'm not going to go into the details here, but there are lots and lots of mechanisms you can put in place to lock down and secure your infrastructure. In other words, which entity can talk to which other entity, how you communicate across the boundaries internally inside your data center in the cloud in your VPC, virtual private cloud. We're going to cover this in a lot more detail in a different module. This is pretty much what I was talking about before, locking down security maybe at the EC2 level. So when you have EC2 instances, you can associate a security group or a set of rules, this is your set of rules, to interfaces on these EC2 instances. And each one of your EC2 instances can have different rules. Okay, like this. Try and do it in different colors. So this one, you might have a security group that says, I'm only going to allow port 80 for a typical website, or port 443 for a secure website. I'm going to allow that, but I'm not going to allow the general public to be able to use port 22 and go straight into this. However, what you could do is you could set up a rule here, run out of colors. This would be a separate rule here to say, I'm only allowing port 22 because I'm going to shell into this particular Linux box here, and I'm going to use that to then send commands to my web tier application tier and database tier, and these two can communicate, but you can't go from here, from the outside world, like that. Okay, so what you're doing is you're creating a set of rules that you're applying to certain groups of machines to allow what can come in and what can go out, and these are your security groups. Everything else is going to get black by default. Just so you know, when you set these things up, you're not allowed access to anything. You have to go in and actively punch holes in your firewalls in order to create these security groups. Everything is locked down by default, and then you start opening the floodgates. So by default, it's secure. Identity access management, this is a term that you're going to hear a lot of throughout the rest of the modules, IAM. When you see this, you just need to think about security. That's why they have this key symbol up here. And the idea is you can manage your users and their access. So when you create an account with AWS, you're given a username and password to be able to log into that root account. The first thing you should do is create a user, make sure that perhaps that's admin, and that admin user then goes in and creates all the other users and assigns groups and this kind of thing. So when you have your users, you associate policies to those users, so that a guy called Bob can access maybe S3, and Jane can access Dynamo. And so Jane can't access S3, Bob can't access Dynamo. By default, no one can access anything, right? So you have to actively say, I would like Bob to be able to access S3. Sometimes if you have a lot of users, it's easy just to set up groups and then assign a load of people to a group and say, well, anyone in this group is allowed access to S3. That might be easier. When you're working with the enterprise, if you're working in the enterprise, you may have your own authentication system. You may be using something like Active Directory, where you have all your users already authenticated via an internal system on-prem. We have a mechanism to allow you to and we'll cover this a little bit later on, but you have a mechanism that lets you use that authentication and get temporary credentials from IAM to access the console, so that your users in your organization can still access AWS, and you can control what they can and can't do with policies, but all the authentication is actually done by you guys with your system, maybe Active Directory. And again, more about that stuff later, because I can even mention something we're going to cover later on called Cognito, and that allows people to log in with, say, Google, Facebook, or Amazon, and then get temporary credentials to do the same thing too. So there's a lot of different things we can do in terms of logging in. So let's talk a little more about this authentication concept. If you've already created an AWS account, you would have seen something a little bit like this, where you have an account and a password. And if you've created users within your root account, you will also have an ability to go in as that particular user. I would recommend MFA multi-factor authentication. This just means that when you log in to this step here and then you click sign in, it's going to take you to another page that then asks for a little code that you've got from a device, or maybe from your mobile phone. You can use some software MFA, and then you would type in a particular code, and then you'd be logged in. It just adds an extra layer of security as multi-factor authentication. Anyway, once you're into your console and you click services, you'll see all of this stuff. And this means you can click on a particular service like EC2 or RDS, and it will take you to that service and you can start interacting with it. So the console is a very nice graphical user interface for you to interact with all the services. Now, of course, you don't necessarily have to use a graphical user interface. You could, if you're a fully authenticated user, make API calls with the command line tools, command line interface, or the SDK, software development kit. You'll be familiar with these acronyms later. So that's how you log into your system. That's what you'll see when you're in the console, but it doesn't mean you have to use the console to interact with the services. I can make command line calls to S3, and I'm going to talk about that now. If you're not using the console and you're using the command line tools that you've downloaded from Amazon to be able to go into your infrastructure, you're going to have to provide credentials. When you make a request to, say, upload something to S3, which is our object store, you don't send across your root username and password in that request. What we use are keys, access key and secret key. Access key is essentially your identifier, so that we know which user we're dealing with. And the secret access key is used to sign the request, meaning that we'll take all the key component parts, such as your access key, secret access key, the resource you're trying to interact with, some parameters for that resource, maybe the file you're trying to upload. We're going to take all of that metadata and we're going to scramble it together using the secret access key, and we're going to create a signed version of that request, so that if someone gets hold of that request, it's going to be very hard for them to unravel what the secret key is and access key and this kind of stuff. That's automatically done for you with all the software development kits. So if you're using programmatic languages like Python or Java or even Node, this stuff is done transparently. It's done behind the scenes for you. However, you still need a key and a secret access key per user, because these software development kits have to find this value and then make that signing request and then send up the request. And even in the command line, even if you're just not using an SDK and using the command line, you still need some way to reference a command line to these values. These values are stored in a simple text file on your computer when you download the CLI or the SDK. And they're stored in a text file once you type AWS configure. You go to command line, type AWS configure, and you type these in that you're given from the AWS console. When you first create that user, you're asked to download these credentials. You download them, you type them in, say which region you're dealing with, what type of format you're interested in, or just leave the defaults. And that will be stored on your system, so that when you have an SDK or a command line, it's going to look in a particular file, and then you're going to be able to sign requests, and everything's going to be nice and secure. Okay? As far as you're concerned, I guess you really don't need to know the inner workings of this. All you need to know is that when you're using the SDK or the CLI, it's not using username and password, using an access key and a secret key behind the scenes, which you get when you create your users. Okay? Let's have a look at these groups. I think this is quite straightforward actually. If you have all these different users like Bob, Jane, Sally, Paul, they're all going to have different permissions for things that they do. Now you could go and attach policies to each individual one, so each one has a different policy for what they can do. But if these, I should probably use different colors. If they're using exactly the same policy, it's better to associate the policy here and actually not give them these policies. If I can find red again, there. It's better to assign the permissions to the groups, so that as long as you've associated user with a particular group, when this user makes requests, whether using the command line or SDK, it's going to look at that access key, identify that particular user, and know, oh, this user is part of this group, so he can access S3. I think that's quite straightforward, right? Now, it's where things get a little more tricky, but it's actually a really good thing that we do it this way. It's a lot more secure. So when you have entities within your infrastructure, that could be an EC2 instance or a Lambda function, we'll talk about these things later on. This EC2 instance is not actually a human being, obviously. It doesn't have, it's not actually a user, so it doesn't have its own access key and secret access key because it's not actually a user, it's a machine. And you may have many of them. So of course you could create a user and call it EC2 user if you wanted to, and so you have a secret key and an access key, and then you copy that on multiple EC2 instances. But that's not such a good idea, is it? Because you have the same user on all of these, and you've got those credentials baked into those machines. Not such a good idea. It also means that very often what people have done in the past is that they've written code, and in their software development, and they use a software development kit, and in their code they're referencing a particular user access key and a secret access key in the code, and then dropping that onto a machine. And again, you're still left with the same problem, that you've got your credentials flying around everywhere and being stored on machines, being stored in your code repository. Even if you delete them from your code repo, you can, with repositories, you can go back in time and then access that. It's never a good idea to be using credentials in that way. So we have a different concept. We have the idea of a role. So you say this EC2 instance doesn't have credentials, isn't a user, but it can assume a role. That role, like users and groups, can have policies associated with them, saying anyone who assumes this role can access, say, S3 and Dynamo. Which means that when you write your code and drop that on an EC2 instance, you don't have to worry about having any credentials in there. You just write your code like normal, and that code might make calls to S3 or Dynamo, and when that EC2 tries to reach Dynamo or S3, it's doing so on the basis of a role. And the role mechanism, without going into low-level details, is providing temporary credentials. So yes, it's using an access key, yes, it's using a secret access key, but they're temporary credentials. Sorry about the scribbling, that says temp. Temporary credentials from our internal system called STS, Simple Token Service, and it's getting temporary credentials so that this piece of code can interact with these services without storing long-term credentials on those machines. This is a much better concept. No credentials on your code, no credentials on the machine. Much, much better. And you can apply the same role to numerous machines. So, talked about adding policies to users, groups, roles. What do they look like? Well, they're just JSON documents. And JSON is nothing more than text. It's just written in such a way that it makes it quite easy to read, and can be used across all of AWS. And we can also use different formats. We can use YAML with CloudFormation. We're moving in that direction as well. So you have different formats. You're not going to be stuck with JSON forever. But just to keep things simple, JSON, JavaScript Object Notation, that's what it stands for. If you're familiar with JavaScript, you'll probably know what this is already in terms of the structure. But all we're doing here is applying certain rules. We're saying that I would like to be able to use certain commands with EC2, okay, providing my IP address, and this range is fully masked out, so it's essentially that full IP address there, okay. That IP address is allowed to do these things, but it's also allowed to access S3. Not all the commands on S3, you can't like delete or anything, but you can get an object from S3 as long as we're going to this specific bucket. I'll talk more about ARNs a little later on, but this is just pointing to a bucket in S3, a storage mechanism. So as long as a user or a group or a role is using this policy, that entity can access these items in this bucket and can access these commands for EC2, providing, again, the caveat here is that there's a slight condition on this action to say that it has to come from that IP address. And that's what a policy looks like. So although it looks a little gnarly, it's actually quite powerful, isn't it? Sometimes things are a little bit clearer with a drawing. If you have this user, let's call him Bob, and Bob needs access to S3. But there's a problem, because Bob's policy, Bob is a user that can access Dynamo, and nowhere on his policy does it specify he's allowed to access S3. So unless it's explicitly allowed to use S3, he can't. So how does he get access? Well, provided you trust, and we're talking you're the admin here, you're trusting Bob to assume this role. So you say, I trust Bob. Okay, and Bob is allowed to assume a role that can access S3. When he needs to access S3, he can. And as long as you have a trust policy in place, Bob is allowed to assume that role and then can access S3, because you're using temporary credentials here. When he's finished working with S3, takes his hat off, picks up these policies. So the important thing to remember, and this is what I misunderstood when I very first saw IAM. I was under the impression that if Bob could access Dynamo and then assumed a role that could access S3, that Bob could access Dynamo and S3, right? Sounds legit. Unfortunately not. The way that, well actually fortunately not, you'll see why later on. What happens is when Bob decides I'm going to assume this role and puts his little hat on, which is this green hat here, he can only access S3. He's left this at home, essentially. Then when he's finished with that role and he takes the hat off, he can access Dynamo again. He's back to where he was before. So it works in a slightly different way as you may presume that you have a combination of the two. It's actually not quite like that. You assume a role and you drop your credentials to pick up that role, and when you finish with the role you drop your role and you pick up your credentials from where you left off. Okay, so that's how it works. Also on this slide, and I'm sure you've already looked at this, is if you're on a different account, you don't want to provide this person account access to this. What you do is you assign a role that says I can access S3 and let this person, providing you trust them because they're a third party that you're working with, to assume that role. So as long as you trust, say, Jane to access that role, Jane can then take that role, assume it, and then access S3 across account. How cool is that? When you're working with roles, I mentioned earlier, we're using a service called STS behind the scenes that's creating these temporary credentials. We're using this even for Cognito, where you're logging with Google or logging in with Facebook and you're getting temporary credentials. It's actually using the same system the role system is using with what we call simple token service. So obviously you're going to get an access key and a secret access key. There's going to be temporary credentials, and because they're temporary, they have an expiration on there. So you can determine that when you set up your credentials. You'd also be using this if you're using, say, Active Directory and using that authentication system to get temporary credentials from AWS to access, so your users can access AWS. It's using the same stuff. As you can see with that animation here, this is just explaining Cognito. You know, a user is going to maybe use a mobile client, and what they're doing is essentially logging with Facebook or Google, and once that authentication is in place, you're then making a request to Cognito, which is our federation service, and that's allowing this STS process that I mentioned before to generate these temporary credentials. Once you have those temporary credentials, they're now temporary and stored on that mobile client, identifying that particular user because you have an access key and a secret access key and an expiration token. You're going to use those credentials to identify the user so that that user can then access things like DynamoDB, and providing the role, I don't think it's shown on here, these are the rules of what that particular user has access to. As long as that has access to Dynamo, because you've identified the user with that policy here, they can access Dynamo. Pretty cool, huh? Notice no EC2 in sight. Pretty cool, isn't it? Because what you can do, and I know it's a little more advanced, but I'm not going to go into the details, but it's a really cool concept, is that you can identify a particular user on an AEM policy and say whatever user is being used to access this can access their own rows in that table. So that means you can have a DynamoDB with everyone's scores and profiles on for your users in your game, but only the particular user can access their particular credentials on one policy. More advanced subject, but it's a pretty cool concept. Know what EC2 is in sight, right? Nice idea. Sorry about the funky animation there. So this is the other concept using SAML. This is actually quite useful because if you have an enterprise that wants to use their existing authentication system with AWS because they want to access a particular service like Kinesis, they can do that using the same concept as you saw with Cognito. So let's see if there's an animation here, we'll explain it. User logs in on-prem with their system, and this could be maybe Active Directory, to authenticate the user. So all this stuff that you see here, 1, 2, 3, 4, this is just general authentication system, traditional authentication that you'd have on-prem. And then you make a request. That's the technical term for it. You don't need to know that unless you're actually doing it. But this application will make a call to STS, and STS will return those temporary credentials for that particular user. So identify the user with an access key, secret key, and an expiration token. And then you use those just like you did with Cognito to access services. Pretty straightforward, right? One thing worth mentioning, you're not supposed to use IAM for application level authentication. You would use Cognito for that. You would build your own authentication system. You're not going to build a web application which collects users and handles passwords and doing all this kind of thing with IAM. IAM is designed to access resources within AWS specifically. It's not designed for operating system application authentication, just to be clear. Let's just wrap up with a couple of best practices. Once you create your first AWS account, you're obviously going to get username and password. We recommend deleting your root access keys, the secret key access key. You don't need them because you should never be making calls as root. What we recommend you do is you create various AAM users, one of which could be an admin that has access to all the resources it needs. Maybe doesn't have access to, say, the billing side of things, and you can control that with IAM policies. And earlier on I showed you that JSON document with a really gnarly set of rules. You don't have to write that from scratch. We have IAM policy generators that make it super easy. So you just go in and say, I'd like admin access, and it would write that for you. That kind of stuff. Or just want S3 read-only access. It would write it for you. So there's tools we have in place to make your life easier. Use groups to assign permissions. If you have a lot of attrition, lots of users coming and going, it's probably better to assign permissions to a group and then assign the users to that group. So if a user disappears, you don't have to worry about whether they have permission or not anymore to that resource. You don't have to cancel those credentials because they're associated with the group. Grant least privilege. That's common sense, I mentioned it before. If they don't need access to S3 but need access to Dynamo, don't give them access to S3. Common sense stuff. You can also choose a strong password policy when you're setting up your users. You can say, I'm going to create this user, give him a temporary password, and when he logs in or he or she logs in to finalize their account and sets their password, it's got to meet certain criteria. A certain amount of characters, certain amount of length, this kind of thing. Set a strong password policy. Also, you should definitely set up MFA for the privileged users, the power users on your account. Make sure that you have some sort of MFA device, or you can use a software authentication system. You just go to your local app store and look up MFA. I'm sure you'll find one of the free software authentication systems you can use, and that's just going to lock down your system a little more. Meaning, unless they've got your phone, they're not going to be able to access your AWS account, because you need both together. That's called multi-factor authentication. And a few more best practices, and I mentioned this before, using roles for applications. Don't store your credentials on the machines. You would use roles. And if you want to allow people to access your resources, delegate them via roles instead of passing credentials around. If you are using credentials, you need to rotate them regularly. Don't use the same credentials forever and ever and ever. Keep rotating them. Remove unnecessary users. Remove unnecessary credentials. Don't have them hanging around. If you have a user that leaves your organization and you happen to have a user policy associated with that, delete that user policy. Delete those credentials, or at least disable those credentials if it's maybe leaving temporarily, that kind of thing. Use policy conditions for extra security. I'm going to mention that in a little bit. And of course, monitor activity. So you'd set up something like CloudTrail or CloudWatch to just monitor who's logging in when, who's making what calls when, for full auditing. This is this policy based on the resource. Now, I mentioned before you can set up a user or a group or a role to have a policy that has access to certain things. Well, if you take it from the other side, you can set policies on the resource. So instead of John with his policy saying I'm allowed to access S3 and hitting up S3, this is supposed to be a bucket for S3, you can do it another way around. You can have an S3 bucket with a policy to say only Bob and Jane. So if Paul comes over here, even if he's carrying a policy to say, hey, I'm allowed access to S3, nope, you're not, your name's not down, you're not coming in. This is the policy at the resource level. And certain services have an ability to set those policies in place. This just beds things down a little better. Using the principles, that's what I'm referring to here. Okay? I mentioned earlier on that you want to monitor who did what when. Well, we have a specific service for that, and it's called CloudTrail, and this is going to record all the API calls. Slightly different than CloudWatch. When I first saw CloudTrail, I was a little confused as what's the difference between that and, say, CloudWatch? Well, CloudWatch is monitoring things like CPU usage on your EC2 instances and queue depth on SQS, these kind of things, metrics and what's going on in terms of your entities. CloudTrail is saying who did what when, who made what API call to what service and when did they do it. And it's going to deliver that information into S3, which is our storage mechanism. And then you can look in the console to make sense of what's going on and who did what when. So it's very important that you actually set up those logs on your particular resources in particular regions. And that's it. So let's just wrap up by seeing if you know the most important answer to this question. Your web application needs to read-write to a DynamoDB table and an S3 bucket. It requires AWS credentials to do this. It needs authorization to use AWS services. What service would you use? Tick tock, tick tock. Roles. Hopefully you got that. Hopefully you got that right first time. Okay, awesome. So just to be clear with IAM, you assign policies to users, groups, or roles, and it's based on least privilege. And if there's anywhere in any policy saying someone can't do something, that will override any policy that says they can. So you write a policy to say John will never access Dynamo. A year later he joins a development group that says, oh, developers have access to DynamoDB. He will not have access because it's an explicit deny. That's just one other important point you need to remember. I think that's probably all we need to talk about in terms of IAM, at least at this essentials level. Now let's move on to the next module.